Hi, we're going to go ahead and continue this inference with proportions review. The other video did 1 through 15, and so this one will do 16 through 20. Now, this one, number 16, is asking us what happens, what do we need to do to the sample size so that the margin of error is cut in half, okay? So again, the critical first step that you do is you set up that margin of error equation, okay, where you had that margin of error is that part of the formula behind the plus minus, okay, and so that's the critical value and then your standard error. All right, over n. Now, what I'm showing here is that in order for the margin of error to be cut in half, we need to come in here and multiply that the sample size by 4. And the reason we have to do it by 4 and not 2 is because of this square root symbol. See, so when we have that square root of the 4 on the bottom, then that comes out as 1/2. Okay, so then that's what makes the margin of error half of its previous size. Okay, so multiply the sample size by 4. Likewise, this next one is asking what happens if we want the margin of error to be 1/3 as big? Well, in order for us to get the 1/3 here, then that means that what's inside the square root is the 9. Okay, so that when we are doing that square root of 1/9, we are then getting this 1/3 right here. Okay? All right, and then number 17 was a 2 proportion problem. Now, the thing that I want to do on this one is really make sure that you are clear in your understanding of this problem and clear in exactly how you are defining your parameters. Okay, I know we're getting to where we know all these steps and everything, but let's take a look at what this problem is really about. So first of all, what this problem is saying is that there were some defendants in San Francisco County. And whenever they are in San Francisco County, they first go into their case by pleading, doing the plea of guilty, or some of them go into the case and they plead not guilty. So, of those defendants who say, okay, I'm guilty, then they automatically get sentenced, okay? Then we want to see of those who say, yep, I'm guilty. We don't need to go through the whole rigmarole of the whole jury and the whole court case, okay? At least that part of it. Then of those ones who pleaded guilty, what proportion of them actually ended up going to prison? Okay, and so then over here on the right hand side, same thing. These were ones that said, hey, you know what, I'm not guilty, and then they go through the whole trial, and then we see what proportion of those ones that had to go through the whole trial and were found to be guilty, how many of those were then sentenced to prison. So is the fact that you pleaded guilty or not guilty affecting the rate at which you go to prison? So look at the parameters here. So this first one says the proportion of defendants, okay, the proportions of defendants from the San Francisco County, you know, so all these ones in this particular location. So this is what's happening there. Who plead guilty. So the denominator is the defendants who plead guilty and get sentenced to prison. Now, you know, I probably ought to even have put in here, they plead guilty and are found guilty, you know. Or I could say the proportion of judged guilty defendants. I could have put this phrase in here. The proportion of defendants that were judged guilty, okay, who pleaded guilty from the start, but then get sentenced to prison, okay? And P2 is the proportion of defendants that were judged guilty, the proportion of judged guilty defendants from San Francisco County who pleaded not guilty from the start, but then are sentenced to prison. All right. So that's the big deal. The rest of this just kind of follows straight through, no problems. Our null hypothesis that those two amounts are equal. Alternatively, it asked if they are different. It didn't specify one's higher or lower. Okay, assumptions. Now, look here, I did this for both of them. So randomly selected 199 defendants who plead guilty, 128 defendants who plead not guilty. Okay, independent. N is less than 10% of the population. So 191 is less than 10% of all defendants who plead guilty. 128 is less than 10% of all such defendants who plead not guilty. And remember, with two proportions or two, and two means, when we had those two separate items, it's important that we say that those two sets of defendants are independent of each other. Okay? Now, when I did my large enough is tricky because it all depends. Mean or proportion. Mean is 30. Proportions is 10. At least 10 successes and at least 10 failures. So there were 101 sentenced to prison and 90 not sentenced. So that's the successes and failures of the pleading guilty group. That's greater than or equal to 10. And here the 1, 12, and 16 both greater than or equal to 10. So approximately normal model applies. This is a two proportion Z test. So I went and I put this into my calculator. Okay. And I got this Z score, negative 6.43. So it's way down there. And then look at this p-value. It wasn't 1.25. It was 1.25 times 10 to the negative 10. So that's like this here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10. Okay, that's pretty much 0. So our p-value of 0 is less than the alpha. Notice that the alpha they said in this one was 0.01. Okay, so don't just always assume it's 0.05. Pay attention, you want to double check that. So since that p-value is low, reject HO. So since that p-value is low, I have evidence that, there is evidence that HA, the proportion of defendants who plead guilty and go to prison, is significantly different than the proportion of defendants who plead not guilty and go to prison, and from San Francisco County. All right, the next one, number 18, was also two proportions, but it was asking for an interval. It was asking for you to estimate the difference between those two proportions of new strain and parent strain trees who get the serious apple rust infection. So my parameters, I had this first one, the proportion of all such trees with the new strain. Remember, you're always including that treatment, or that something special that's different, who get serious apple rust infection by the end of 3 years. The other one is the proportion of the trees with parent strain, proportion of all such trees, because these are the populations. We are going to make an inference about the population, not just about our sample. Okay? So that's the populations we're going to be inferring to. So when we do our assumptions, they are about both of those sets. The 50 new strain trees and the 100 parent strain trees are assumed to be randomly selected from all the trees of those types. So then independent that those 50 are less than 10% of the new strained trees, I guess this is apple trees, and 100 is less than 10% of all the parent strain trees, and that these two trees groups are independent of each other. Okay, so then the large enough, at least 10 successes and at least 10 failures. So for the new strain, there were 22 that got the infected, which meant 28 did not. Parent strain 61 got infected, 39 did not. So those meet the large enough, therefore approximately normal model applies. We have the 2 proportion Z interval. Notice when you write your interval, it makes sure that you include the way you are subtracting. If you did not have this here, okay, I don't know where else you were going to put it. See, otherwise, we do not know how is the subtraction happening. We want to find the difference between them. Okay? So then we have our interval. And I see it went from a negative number to a positive number. See, so in my mind, I'm already thinking, okay, I need to make sure I get this notated or stated correctly. So I am 99% confident that, so I'll talk about that first item, the proportion of the new strain trees who get the serious rust infection is between 39% lower than, because of the negative, up to, then it's positive, so 5% higher than. So the new could be 39% lower, but it also could be up to 5% higher than the proportion of the parent strain trees who get serious apple rust infection. Now, it doesn't matter that a whole bunch more was lower than the part that was above. Doesn't matter. Because 0 is in that interval, then there is no evidence that there is a significant difference in the rate of the apple rust infection amongst the new strain and the parent strain. Okay? All right. And number 19. Shoo-wee. Number 19 asked to put a whole phantoms in that little bitty space there. I don't want to go over the whole thing. It's pretty straightforward. But I did want to point out one thing. This was an experiment, okay? Because we took the 1,000 adult volunteers and they were randomly assigned to the treatment groups. One which took the low dose aspirin every day and one of them who took the placebo. So, but make sure in your parameters you said the P of A was the proportion of all such adults who take the low dose aspirin. If you stopped right there, if you stopped your description of your parameter right there, it's wrong. It's not just the proportion of adults who take low dose aspirin. It's the proportion of adults who take low dose aspirin who end up developing colon cancer by the end of 6 years. Okay? So you have to continue it out. I mean, it has to be clear. Who are you generalizing to? What are you saying specifically you are looking for? And so the same thing with the other one. It's the proportion of all such adults that take the placebo. Why placebo? Because I'm thinking we can't necessarily force our body to have colon cancer or not. I think maybe a lot of it has to do with the stress in our gut area where all of the colon stuff is going through there, all the bacteria. Maybe if you think you're taking the pill, you're going to eat better because you don't want to develop colon cancer. You're going to try and be less stressed, whatever. So I think they think there are some behaviors that could be affected by you thinking you're in this study and that you might be taking the correct medicine. Okay, so that's why they did a placebo. Probably because your behaviors might get changed. All right, so then we go through all of the regular stuff. But one thing I wanted to point out to you is this piece right here. In this problem, these were, I think, volunteers, okay? But because this was an experiment, and we had those 2 different treatments, we need to make sure that we are stating not randomly selected, but that these adult volunteers are randomly assigned to the two different treatments, the low-dose aspirin or the placebo, okay? And so that's what's here. You will get that wrong. You will not get credit if you say randomly selected instead of this random assignment because it's an experiment, okay? All right, the rest pretty much you can check that. It's straightforward. I did a 2 proportion z-test. It wasn't, way a whole lot lower than alpha of 0.05, but it was lower, so I rejected a Joe. So I have evidence that to suggest that the colon cancer rate is significantly lower among all such patients who take the low-dose aspirin as opposed to the placebo. Oh, this is a good one. This then, number 20, takes us into connecting our conclusion we made from our test to the results of an interval. So let's take a look here. So they define the way in which they subtracted. That's the way we did too. Low dose aspirin minus the placebo. Okay? And they got those things. So does this decision that you made in the hypothesis test up in problem 19, not number 16, so that was my bad. In problem 19, concur with the decision we would make with this interval we got? And say why. So make sure you answer the question, yes, it does concur. And why? Because the test gave me significant evidence that the low-dose aspirin proportion is lower than the placebo proportion, okay? And that concurs with the interval. Here's why. And so I'm explaining that. The interval is completely below 0, which implies that there is significant evidence that the proportion on the low-dose aspirin who get colon cancer is lower than the proportion of the placebo who gets. So I kind of shortened it and just did the little letters there. In fact, I'm 90% confident that P of L is between 4.26 and 0.14% lower colon cancer rate than proportion of adults on the placebo. All right, so that was your connection, final problem to connect a test and an interval. All right, that is the end of the inference with proportion review.